Now we need to write the conjugate of this complex number and then multiply them together. Just like with radicals, for our conjugate, we are going to just switch that middle sign, just the sign for the second term, keeping the first term the exact same. So our conjugate is 4 minus 3i, and now we need to multiply them together. So we have 4 plus 3i times 4 minus 3i, and if you remember when we were talking about conjugates for radicals, if we were to FOIL this, the outside and inside terms would just cancel out anyway, so all I need to focus on is the first with the first and the last with the last. So 4 times 4 is 16. 3i times negative 3i is negative 9i squared, but I squared is negative 1. Negative 1 times negative 9 is positive 9, so we have 16 plus 9, which is 25. Now if we have these fractions, just like with radicals, I cannot be in the denominator. The letter I, the imaginary number, cannot be in the denominator. That's because I itself is a radical. We can't have radicals in the denominator, so we can't have I in the denominator. So we're going to multiply the top and bottom by our term with I. Now here, since it's I by itself, all that we need to do is multiply the top and bottom by I. So then on top we have 3i over I squared, and as we are well aware, I squared is negative 1. We have 3i over negative 1, which simplifies to negative 3i. Here we need to multiply by the conjugate. So I'm going to multiply everything by 3 minus 5i. And just like before, when we get to the denominator, we just care about first with first and last with last. But in the numerator, 4 times 3 is 12. 4 times negative 5i is negative 20i. Over 3 times 3 is 9. 5i times negative 5i is negative 25i squared. And now we simplify. 12 minus 20i on top over negative 25 times I squared is negative 25 times negative 1, which is positive 25. 9 plus 25 is 34. And now we reduce. Everything here is divisible by 2, so I'm just going to start by dividing everything by 2. I've got 6 minus 10i over, and then 34 over 2 is 17. So that's as simplified as that gets. Here we need to write the complex number in standard form. So in order to do that, in number 17, I'm going to start by multiplying by the conjugate, 4 plus I, because remember I only care about the conjugate for what's in the denominator. In the top I'm going to FOIL completely. 1 times 4 is 4. 1 times I is I. Negative 2 times 4, negative 2i times 4 is negative 8i. Negative 2i times I is negative 2i squared. Over, now I only care about first and last. 4 times 4 is 16. Negative I times I is negative I squared. Now we know that negative 2 times I squared is positive 2. So now we have 4 plus 2, which is 6. Then minus 7i over 16 minus negative 1, which is 16 plus 1, so we're over 17. This one is in standard form, or you could rewrite it as 2 separate fractions. Either one is fine. But I'm going to leave it like this. Now we have 4i cubed minus 6i squared. We don't want to have any exponents with I, so I'm going to go back to my chart and say, okay, what is I cubed? I cubed is negative I, so I'm going to rewrite that as negative I. So I have 4 times negative I minus 6, and I know I squared is negative 1. That leaves me with negative 4i plus 6, but it needs to be in standard form. So our integer needs to be up front, and then our term with I needs to be at the end. That leaves us with 6 minus 4i.